Here's lesson 5.3, the sum and difference formulas. We use these primarily when we want to know sine, cosine, tangent values of angle measures that we're not really familiar with. For example, the sine of 75 degrees. So what we're going to think about with that is the fact that 75 itself is the sum of 30 degrees and 45 degrees, which is so using idea and up here the fact that we have a sign of a sum, we are going to replace every time we see a U, we're going to replace it with 30 degrees. And every time we see a 45, every time we see a piece, we'll replace it with a 45. So we follow the pattern, the sine of 30 degrees, 45, plus the cosine of 30 degrees times the sine of 45. Now, does it matter which is U and which is V? No, it does not. It's addition. It doesn't matter. So now, at this point, we're going to go back and fill in what we know from our unit circle. The sine of 30 is 1/2. Cosine of 45 is root 2 over 2. The cosine of 30 is root 3 over 2, and the sine of 45 is root 2 over 2. And do our multiplication first. We have the square root of 2 over 4, and the square root of 6 over 4. And since they have the same denominator, we put over 4 and simply add. So it's square root of 2 plus the square root of 6. Notice we cannot simplify that anymore because there are different radicals, and square root of 2 plus square root of 6 is not square root of 8. So we can leave our answer like that, and that's good enough for us. Okay, here's an example of a cosine, and this time I got a fairly small angle, 15 degrees. So I think what I'm going to do with that one is say that that's the cosine of 45 plus 15. So this is my U, and this is my V, and notice I'm using the difference formula for cosine. So it is the cosine of 45 times the cosine of 30, and I add to it the sine of 45 and the cosine of, sorry, not cosine, that's sine of 30. Cosine, cosine, sine, sine. Cosine. And then we go back and we fill in what we have. The cosine of 45, root 2 over 2, cosine of 30, over 2. 45, root 2 over 2, and the sine of 30 is just a half. This is looking very familiar. Square root of 6 over 4. So it is square root of 6 plus square root of 2 all over 4. And we can leave it like that. If you wanted a decimal, you can add it out and divide. Simplify by yourself. I will put the answer down here in just a moment, so you may want to pause. But you're evaluating the tangent of 165. And here's your hint. Try this on your own, using the formulas above and knowing that 165 is 120 plus 45. Now, there are more ways that we could do this, but this may be one of the simpler ways. We're just looking for angles that we already know on our unit circle and how we can add or subtract them to get an angle measure that we're not familiar with. Okay, go ahead and pause it, work on it yourself, and I will write down the answer. Alright, radian measure. not quite as intuitive in terms of adding and subtracting. So this one, pi over 12, denominator of 12, we don't know any of those. So you can either convert these into degrees and approach it that way, or you can think in terms of fractions. To have a common denominator of 12, well, it could have come from denominators of 4 and 3. For example, it could have been the cosine of 4 pi over 12, which, remember, that's just pi over 3. Take away from 12, or sorry, 3 12, half a difference of 12. In this case, you have 4 pi over 12 minus 2 pi over 12, that's 1 pi over 12, that's exactly what you get. Simplifying these down, you get pi over 3, and this is pi over 4, and nothing clear. And we're, again, using the difference. So it's cosine, cosine, sine, sine. Cosine of pi over 3 times the cosine of pi over 4. The sine of pi over 3 times sine of pi over 4. And this one, half cosine of 2 over 2. Sine pi over 4 is root 2 over 2. So it's root 2 over 4. 6 over 4. And same answer again. Root 2 plus square root 6 over 4. And those are all the examples that you have on the front side of your notes. And now you can watch the video for using sum and difference formulas in proof.